Okay, so now we've got a box sliding down a 38.5 degree ramp. Okay. Okay, so there's our 38.5 degrees. The acceleration of gravity is 9.8. Determine the coefficient of kinetic friction between the box and the ramp. Oh, all right, this is two questions here. So we've got our friction, we've got our normal, and we've got our mg. For this question, it's going to be easier to just define my x direction as down the ramp and my y direction as up this way. If we draw our perpendicular, then this here is our 38.5 degrees. So our mg force here can be decomposed into mg cos 38.5 and mg sine 38.5. And to give them some direction here, right, there's going to be pointed down and pointed down. So if we look at our sum of forces in the y, this equals our normal force minus our mg cosine of 38.5 degrees, which equals 0 as the box isn't moving up or down in our y direction. So our normal is just mg cosine of 38.5. Okay, and now if we look at our x direction and using our friction force is mu n, so it's mu mg cosine of 38.5. Our sum of x forces is our going in the positive x direction is our mg sine 38.5. And we're going to subtract our friction, which is mu mg cosine of 38.5. And this equals our ma. And we're given in the question that the acceleration is 1.39 meters per second squared, and we're asked to solve for our mu. So first of all, we can cancel all our masses and divide out g. So we have that mu, and then rearrange here. So we have mu g cosine of 38.5 is equal to ax minus g sine of 38.5, or dividing the whole thing by that factor to have mu on its own. We have that our mu is, oh yeah, sorry, that was my mistake here. It should be minus a. So mu is sine of 38.5 minus a over g all over the cosine of 38.5, which comes out to 225 minus 1.39 over 9.8. Both of these are meters per second squared. We can see that these units will cancel. All over 0.7826. Running this on our calculator, we get 0.6142. So there's our coefficient of kinetic friction for the ramp. If we check the solution just for this first part, then it looks good, 0.614. Okay, so going back up to the second question that we're given here. So we have a 1 kilogram block, an 8 kilogram block, and a 6 kilogram block, all on a table without friction, and we push it from the left and we push it from the right. So FL equals 11 newtons, FR equals 8 newtons, and it wants to know what is the force of the 8 kilogram block, or what is the force on the 8 kilogram block by the 6 kilogram block. Okay. So first of all, let's treat the whole system as its entirety. So that would be a mass of 8 plus 6 is 14 plus 1 is 15. And we've got our FL and our FR. And so then our F net is 11 newtons in the positive direction, so I'm going to use that as my positive x and that as my y, minus 8 newtons in the negative, so that's 3 newtons total. So the acceleration of my system is m. So F net is ma, so 3 newtons is equal to 15 kilograms times my acceleration, which means that my acceleration is 3 over 15, which comes out to be 0.2 meters per second squared. So we can get all of our net forces now on our individual blocks, as they're all traveling with this same acceleration. So for the and we can not only get our nets, so F net for our 1 kilogram is equal to 1 kg times 0.2 meters per second squared, which comes out to be 0.2 newtons. Our F net for our 8 kilogram block is 8 kilograms times 0.2, which is 1.6 newtons, and our F net for our 6 kg block is 6 kg times 0.2 meters per second squared, which is 1.2 newtons. Okay? So those are our individual forces on those blocks. Now we can decompose our 8 kilogram block to figure out, so it's going to get a force from the 6 kilogram block, which I'm going to call F6 kg, and a force from the 1 kg block, which I'm going to call F1 kg. And so F6 kg is what we're looking for, and F1 kg we could find, but it's easier if we look at our 6 kilogram block, because it has a force from the right and a force from the 8 kilogram block. And I'll end up messing it up if I if I use this kind of terminology too much, but we know from Newton's third law that our F8 kg here is equal to minus our F of our 6 kg. So we can get our force of our 6 kg by solving for this F8 kg. So our F net on our 6 kg block is F8 kg minus Fr, which is equal to this 1.2 newtons. And so our F8 kg, our force from the right we know is 8 newtons. And so that equals this 1.2. And so our force from our 8 kg block is 9.2 newtons. Which makes sense, as to get that acceleration we need to surmount that right force. And so that means that our F6 kg is minus 9.2 newtons. So that's the force that the 6 kilogram block is applying to the 8 kilogram block. Okay. So if we check our solution here, so we solve for acceleration, we can get each of our individual F nets. Use Newton's third. And then it just takes it as they just take it as a fraction, which doesn't work here because if the force of our 8 on our 6 or our 6 on our 8 was only 1.2 newtons, it wouldn't actually surpass the force from the right, and then the 6 kilogram block would actually be moving backwards, which is impossible. So error in second question. Should be 9.2